All right, let's talk about machine learning models. We're going to cut right through all the confusing jargon and give you a really simple, powerful way to understand how they work and, more importantly, how to know which one to use.
So here's our game plan for today. First, we'll nail down what a model even is. Then, we're going to meet the three main families of machine learning. Each one has its own, let's say, personality. And we'll wrap it all up with the most useful part, how to pick the right tool for whatever job you're trying to do.
Okay, first things first. What in the world is a machine learning model? Before we can get into all the different types, we've got to be on the same page about what we're even talking about. I'm sure if you've looked into this stuff at all, you've been hit with a flood of crazy names like neural networks or random forests. It's a lot, right? It can feel pretty overwhelming. So the big question is, where do you even begin to make sense of it all?
Here's probably the easiest way to think about it. A model is just a recipe. Seriously. It takes ingredients, that's our data, and it tries to do something, like bake a cake. But here's the magic part. Every time it bakes, it learns from how it turned out and tweaks the recipe to do better next time, all by itself.
And here's the real secret to getting a handle on all this. We can take every single one of those complicated models out there and sort them into just three main families. And the only thing that separates them is how they learn. So let's jump into our first category, supervised learning. The best way to wrap your head around this one is to imagine the model has a really helpful teacher guiding it through every single step. So the key thing here is that this teacher gives the model a whole bunch of data that's already labeled with the correct answers. It's kind of like giving a student a practice test that already has the answer key in the back. The model makes a guess, checks the key, and learns from its mistakes. Now, the catch, of course, is that someone has to create that amazing answer key, and that can take a ton of time and money.
And this student model is really, really good at two main jobs. The first one is called classification. That's all about sorting things into buckets, is this email spam or not spam? The second is called regression, and that's all about predicting a specific number, like forecasting the price of a house next year.
Okay, so what happens if you don't have a teacher? What if there's no answer key at all? Well, that brings us to our second family, unsupervised learning. And for this one, let's think of it as the detective. The whole job of this model is to just dig through a massive, messy pile of unlabeled data and find interesting patterns and structures all on its own. It's like a detective showing up to a crime scene with zero leads and just being told, figure out what happened here. The only challenge is the clues it finds don't come with little notes explaining what they mean. It can point out a pattern, but it's still up to a human to figure out if that pattern is actually important. And our detective here basically has two main moves. The first is clustering. That's grouping similar things together. A great example is a company grouping its customers into different segments based on what they buy. The second move is association. This is all about finding those hidden relationships, like a grocery store figuring out that, hey, people who buy diapers on Thursday nights also tend to grab a six-pack of beer. Now for our third and final learning style, and this one is a whole different beast. This is reinforcement learning. And the absolute best way to think about it is like a dedicated gamer who's trying to get the high score in a brand new video game. This model learns by pure trial and error. It's in some kind of environment, it tries to do something, and then it gets feedback, a reward if it did something good, or a penalty if it messed up. This is incredibly powerful for solving really complex problems, like self-driving cars or mastering a game of Go. But the trade-off is huge. It can take a mind-boggling amount of practice. We're talking millions, even billions of attempts in a simulation to get it right. And it all works through this simple but really powerful learning loop. Step 1, the agent looks at its surroundings. Step 2, it tries something, it takes an action. Step 3, it gets feedback, either points or a penalty. And finally, step 4, based on that feedback, it learns and adjusts its strategy for the next try. It just does this over and over and over again until it becomes an expert. So there we have it, our three families, the teacher, the detective, and the gamer. Now for the million-dollar question. With these very different ways of learning, how do you actually figure out which one is the right tool for your specific job? Think of this slide as your ultimate cheat sheet. It's actually pretty simple. If you have data that's already labeled and you want to predict a specific outcome, you need supervised learning. If you have a ton of unlabeled data and you just want to find out what's hiding in there, you go with unsupervised. And if you need to learn a whole sequence of actions in a changing environment, reinforcement learning is what you need. It really all boils down to the data you have and the question you're trying to answer.
And that brings us to one last really critical question. It's a trap a lot of people fall into. They just assume that the bigger, more complex, more powerful model, like a huge neural network, is always the best choice. But is it?
And the answer is a huge, resounding no. In machine learning, a goal is never, ever complexity just for the sake of it. It's all about finding the simplest, most direct path to a useful answer. The best model isn't the one with the most bells and whistles, it's the one that actually gets the job done.
So the next time you hear about some crazy new AI model, don't just ask, wow, what can it do? Instead, just remember the three families we met today: the teacher who predicts, the detective who discovers, and the gamer who strategizes. Because the most important thing to take away from all this is simple. Choosing the right model isn't about finding the most powerful tool. It's about asking the right question.